Okay, in the social studies video, I told you I would look up bauxite, and I Googled it. The word is Bauxite. It is something we mine for in Arkansas, and it is rich in aluminum ore, which means they can crush it and melt it down to a certain degree, and out comes the element aluminum. And then they use it to make foil and all sorts of metal things that you see that are bendable. Paper clips and such are made out of aluminum. So that's one of the main exports from Arkansas. Check this picture out for your science. I went backward to E1. Y'all know how much I love those windmills that dot the landscape of Kansas and Texas. These blades, 3 blades and the post, some of them are made in Arkansas. Another thing we export, because we don't use them here in Arkansas, we use them in Kansas and Texas because they have lots of wind and nice flat space. Forces in motion. There's a good Bill Nye video for this. Of course, there's always a good Bill video. This is called bobsledding. There's a cute movie I used to watch. It's called Cool Runnings. It's a Disney movie, actually, but I don't know that it's rated G, so you'd have to ask your parents. But anyway, the boys from Jamaica, which is a country in the equator, don't qualify to run in the Olympics as a team, so they decide to join a different team sport, and they join the bobsledding team. And there are actually 4 grown men shoved into this sled, and it goes down a long tube of ice. You can see it there. So they are moving. There's no motor, no engine, no gas. I do think there's a handbrake in there. And the ice, they just navigate up or down or in the center of the wall. They catch pretty good speed. Speaking of speed, that's what our chapter is about today, motion and speed. Our words are position, which is your placement, distance, how far. Motion is a fancy word for movement. And speed is the rate at which you move. Have you ever been to a pond? Many animals live there. Each animal, in fact, moves in a different way. A snake slithers, fish swim, turtles crawl, frogs hop, and birds fly. Check out this lizard guy. How does he move? Yeah, he kind of walks. He kind of slithers and trots or runs, maybe crawls a little. He's got several different ways he can move. Do you think he moves faster than a fish? How would we find that out? How would we determine if you're right or wrong? Yeah, we could use a stopwatch and make sure that they both started at the same place and then say, go. But I bet they wouldn't do what we asked them to. It's a fish and a lizard. They're probably going to run away because we're predators to them. How do you know if something has moved? Look at the 2 pictures of the snail. How do you know that he has moved? Well, you know that he has moved because he changed position. He was at the top of the leaf and now he is at the bottom of the leaf. Position is the location of an object. The snail started out at one end and then ended up at the other. It changed its position. Check out the ball player. Does he change position? What about the ball itself? It went from behind him to in his glove. So words like your prepositions, above, below, left, right, ahead, behind, those words all give us clues about position. That could have been a spelling word for week 25. All right, distance. You can measure how far things move by accounting for distance. Distance is the length between 2 places. When an object moves, it goes from a starting position to an ending position. Measuring the length between the 2 gives you its distance moved. Knowing the distance tells you how far the object moved. She's got a ruler out. If it's a longer distance, you could use yardsticks, and then you could go on to miles. Check out the cheetah. The cheetah is in motion at pictures 1, 2, and 3, but not at 4. Okay, well, we know this because an object must change its position in order to be categorized as in motion. So here he's changing his position, but right here he's popping a squat. He's done. As the cheetah runs, it is in motion. It travels a distance from the start to the finish. It also changes direction. Finally, he stops. Some motions, such as those of a moving snail, are quite slow, whereas a cheetah is super fast. A cheetah runs faster than a person. In fact, the cheetah has a greater speed. Speed is how fast an object moves over a certain distance. So like if cheetah had a friend and they both started at the same place and then they ran, we would see who crossed the finish line first. They would have a faster speed. Fast-moving objects go long distances in a short period of time. Slow-moving objects take longer to travel the same distance. So fast-moving objects would be the cheetah. Slow-moving would be the snail. So imagine a cheetah and a snail at the same starting point. And then who would finish first with the shortest amount of time? Yeah, the cheetah. Bye-bye, snail. To measure speed, you will need to measure time and distance, how long it took, and how far they went. The distance an object travels in a period of time tells you its rate of speed. This is where we're going to do some math. Speed is the distance divided by the time. So in order to find speed, don't write in your book, please. This is my book. You would do distance divided by time. So if they went 100 feet in 10 seconds, 100 divided by 10 equals 10 feet per second. Yeah. So 100 divided by 10 equals 10. And then you would say feet per second. You're going to have to include the distance and the time in your answer. We'll practice those. I've got a handout for you. Just a little bit of math and science. Hopefully this section's pretty easy for you. It's mostly just vocab. All right, this map, Panda Path, Rhino Road, Seal Pool, and Walrus Way. We've covered this in social studies. There's a map key with a scale. It's got images. Then we have pictures and the outline of our place. This is a map. We can go north, south, east, and west. Every map shows which way is north, right here on a compass rose. It will help you find places. So if we start at the Seal Pool and go north, we're going to hit Panda Path. And if we go northwest and then back north, we would find and hit the rhinos. Maybe this is a zoo. If we started again at the Seal Pool and went east, we would hit picnic tables. I know that because my key says so. If we again started the seals, I like this part because it's in the middle, and went to the west, we'd run into the chomping alligators. Maybe this is the exit here where the key is. That's my theory. All right. This map also has a scale. The scale helps to measure the real distance between these places. So it looks like if I put my thumb down, and my thumb's going to be bigger than yours because I'm grown-ish. So from the end of my finger to almost my first knuckle is 100 feet. So 1 inch. So Alligator Alley is 100 feet, 200 feet, maybe 150 feet from the Seal Pool. I hope they don't eat those guys if they got escaped. And then from the Seal Pool to the Panda Path, I got it right at about 100 feet again. Everybody's thumb is different. That would be better if I used a ruler to really determine the exact distance. And then in order to know in real life, because a map is not as big, I mean, look, my hand is almost as big as it, you would have, the scale would have a conversion. So 1 inch is 100 feet. So this is 1 inch, but really it's probably more like a half a mile at a zoo. So you'd probably have another conversion on there. All right, if you have any questions on your science for today, let me know. See you later.